Thank you. My talk today will focus on strategies for becoming more diverse and inclusive. The first question I think we need to address is, why does diversity matter? Is it just the right thing to do, or is there some more intrinsic value to it? Well, studies have shown that higher rates of diversity help institutions evolve, innovate, problem solve, and be more efficient. Also, highly diverse and equitable and inclusive workplaces offer employees and students a better sense of community, increased engagement, and a more positive culture. And I think for the geosciences, there's an additional benefit. A geoscience community that pulls from the greatest breadth of society will gain from diverse life experiences and perspectives, and that will provide unique insights into solutions to geoscience-related problems facing society. Also, effective engagement with all affected communities that are facing these problems, and the added benefit of engaging the entire student-employee population, which gives us access to a greater range of talent and allows us to compete for the very best minds. In order to increase diversity and inclusion, we need to build positive department and/or institutional cultures and sense of community. The first step is developing robust diversity, equity, and inclusion plans. This may require people to engage in uncomfortable conversations, but it's something that's necessary. Faculty, students, and staff also need professional development. They need to learn about cultural sensitivity and implicit bias and microaggressions. They also need to be able to recognize and understand lonely onlys, the imposter syndrome, and stereotype threat. They also need to learn how to mentor effectively and recognize power imbalances and how to handle those. It really helps if departments and institutions have guidelines for behavior, basically expectations for the members of that community. I'm showing on the right a webpage from the Jackson School where we have guidelines posted for behavior. Everyone within the school downloads these, reads them, and signs saying that they have read them and that they understand them. But if we're going to address diversity, we really have to start with students. Geoscience enrollments are the least diverse in the sciences. If you look at the graph on the left, it's plotting the percent science and engineering degrees awarded to underrepresented minorities. And the circled red area is the geosciences, and you can see we are clearly the lowest in terms of our percentage of underrepresented minorities. If you look at the graphs on the right, these are for PhDs. The upper one, the black line, are white non-Hispanic, and all of the other minorities are shown in the colored lines, and we clearly have a long way to go. If you look at the bottom graph, we're looking at gender over time for earth sciences, and the purple is male and the blue is female, and you can see that we have done much better in terms of gender balance. But we need to recruit, retain, and promote the success of all students with an emphasis on those that are underrepresented in the geosciences. So in terms of broadening diversity, we need to build the pipeline. But we have many challenges. Overall, the public has a total lack of awareness of what the geosciences are, both as an occupation and the types of professions, as well as their impact on society. We also have a problem in terms of underrepresented minority families accepting the geosciences as a viable occupation. And of course, our lack of diversity doesn't help either. If you look at the photograph on the bottom right, if you're a minority and you look at this picture, do you see anybody in there that actually looks like you? So we have many perceptions out there and negative ones that we need to overcome. In general, the view is that geosciences have low pay, they're low prestige occupations, they're low tech, which this group clearly understands is not true, that it's an easy science, that it's manual labor. If you're doing work out in the field, it must be manual labor. and that you're required to travel a great deal and be away from home. Clearly, the geosciences need better marketing. So what are some pathways for attracting students into the geosciences and into careers? Well, some of the marketing positives would be to emphasize the ability to make a difference by solving problems of societal importance. This is something that's very, very important to young people these days. Also to stress ties to the local community and culture and societal aspects of the problems. This will help a great deal with minorities leveraging interest in innovation, high-tech fields also is very appealing to parents and students in underrepresented minorities. And we need to provide information on salaries, careers, and employment rates. Geoscience occupations are well compensated. We have robust employment opportunities. The graph on the right shows recent data from September of the Bureau of Labor Statistics, and they predict in the next decade 4 to 8% employment growth for the geosciences. It's also important to stress that most geoscientists work on computers or in labs, and working in the field is a choice, it's not a requirement. Another thing we can do is recruit from other disciplines. If you look at the demographics of most universities and colleges, they are more diverse than they are in the geosciences. This gives us an opportunity to try to recruit from other students within the university, and we can use the chance to use quantitative and computational skills to solve societal problems to help recruit students. We also need to promote the success and retention of underrepresented students once we have them in our programs. Mentoring is very important. That includes peer mentoring, student to student, faculty to student, and using mixed cohorts, sometimes even intrusive mentoring. Early experiences, formative experiences are important. Authentic research, disciplinary projects or contests, summer research experiences, internships, field trips, and engineering has been very successful with summer math and chemistry bridge programs. Another thing that's needed is to build social and community building activities and spaces, essentially places for students to congregate and feel like they belong. Having students get involved in student groups or chapters also helps develop a sense of belonging, and they become more motivated and confident academically. And we need to provide support networks, safety nets, and tutors, essentially academic, financial, and social support. Another thing that helps a lot is using effective pedagogy. It supports retention and student success. That includes collaborative and active learning, as well as experiential learning. It's also very important to integrate math, chemistry, and physics and computational science into all levels of geoscience courses. That way, students can address these topics in a geoscience context and understand their application and importance to their degree. And encourage and financially support student attendees and presenters at regional and national scientific conferences, but also at conferences like SACNAS and North American Black Geoscientists and Geoscience Alliance meetings and student conferences. All these things build student efficacy as emerging geoscience professionals, and speaking at SACNAS and NABG conferences helps them relate to people who look like them. There are many resources available. Most campuses have multicultural centers. Integrate at the CIRC website has web pages on diversity and examples of things to do. The Department of Education has funded programs that you can apply to. TRIO in itself has 8 programs for low-income and first-gen students. That includes McNair scholarships. Gear Up is also another program that's very valuable. And there's the Lewis Stokes Alliance for Minority Participation. It's an NSF program to assist universities and colleges in diversity in the nation's STEM workforce. One example is at ASU, the Western Alliance to Expand Student Opportunities, but there are many others as well. And of course, there's many NSF-sponsored and supported REUs. Here's just a list of some of them that are relevant to computational geosciences. UNAVCO has 2 that are focused on solid earth geosciences and geodesy. University of Maryland, Baltimore County has one in high performance computing, including parallel and statistical computing. And the University Corporation for Atmospheric Research, UCAR, has 3 in addition that are very computationally focused. And there are many more. And you can always start your own. Give you an example of one we did this summer. GeoVISION, Geoscience Visualization, Simulation, and Imaging Online Networks. It was an 8-week virtual program, and it was to prepare diverse undergraduate students for graduate school and/or careers. The focus was on computational and technical applications. They had research experiences and skill development. Focus was on data management analytics, computational programming, and spatial analysis. And this was done through lectures, a variety of exercises, and training modules. They all also did a guided independent research project and attended lab research group meetings so that they could be exposed to a variety of geoscience disciplines. We had 23 trainees from different disciplines. Most of them were in the geosciences, but there were undergraduates in other areas as well. And they interacted with 30 different professional faculty, research scientists, postdocs, and graduate students. Another thing that was added to it was twice a week they had workshops that dealt with things like identity in STEM, coping skills, reading scientific literature, applying to graduate school, and internships in the geosciences. They also had social and community building activities like game nights, trivia compositions, and so on. And I think it's important to note that GeoVISION provided spaces for students to connect to STEM majors with similar backgrounds and a learning environment where they aren't the only one that looks like them. And it instilled in students that sense of belonging. The 2 graphs below show answers to questions after GeoVISION and before GeoVISION. After is in blue, before is in gray. Things like, please rate your confidence in your ability to succeed in graduate school, interest in pursuing a career in the geosciences, with clearly a major change after 8 weeks. Also, how well do you know to do the following? Give a science talk or presentation, visualize and present data, analyze data, develop a scientific study. Again, major advances in how well they felt they did. And if you do a program like this, of course, it's very important for you to collect metrics. These are just 2 of a number of graphs that show results of the survey that was done. And there's other ways, many other ways one can try to increase diversity. One is by working with 2YCs or community colleges. They basically mirror the community demographic. And by building relationships with 2YCs, you can increase your enrollments as well as increase your diversity. One thing you have to do is get rid of the cultural bias that underrepresentation does not mean underprepared. And you have to have good communication between advisors at both the 2YCs and the 4-year colleges or universities. And build communities for these transfer students, both before and after they transfer. There's a lot of different ways I have listed here that one can do it, but basically it's making sure that the students that are going to transfer to your university or college have interaction with the students that they're going to be part of a cohort with once they transfer. And the results where it's been done is very successful. Students overall become more successful academically and they're more socially prepared. You can also work with historically Black universities and colleges or Hispanic serving institutions. An example is Fort Valley State. They've had a program since the late 90s. It's a dual degree program in engineering, geology, geophysics, and health physics. They have a number of graduates that have come out that are professionals. It's basically a dual STEM degree, 3 years at Fort Valley State, and then 2 years at the partnering institutions. Another thing that people do in terms of broadening participation of underrepresented groups to increase the pipeline is working with pre-university students, high school students or middle school students. In 2014 and 15, we ran a survey asking how many departments had efforts or planned to having efforts to try to encourage broadening participation, retention of more diverse students. And as you can see, less than half did. Hopefully this has increased. But those that did, if you look at what they have in their program, they all incorporate role models. They all include mentoring, providing financial support, reaching out to students in their communities, and they all involve members of the community, family, high school teachers, guidance counselors, and so on. And so emulating these programs is one way to approach recruiting and building the pipeline. I'll give you an example of just one, GeoForce Texas. It's a high school program we've run since 2005. We identify high achieving students in 8th grade in Southwest Texas and inner city Houston, and take them on 4 years of high school summer trips to some pretty exotic places. We generally have about 350 high school student participants, and the demographics are dominantly Hispanic with a number of African Americans, and the majority are female. We've had over 1,300 complete the high school program. They've all graduated from high school. We have almost 500 college degrees, 50 some masters and 7 PhDs. And there's over 500 GeoForce graduates in college right now and 63 in graduate school, with about 60% declaring STEM majors. And the graphs on the right just show some of the data. If you look at GeoForce in blue, Texas in orange, and US in gray, for high school graduation, college enrollment, and college persistence, GeoForce definitely outperforms. And it's a complete package. It's competitive, it's community involvement, mentoring. We've gained the trust of the community, and although it's expensive, it is successful. Other ways that we can build and nurture positive departmental institutional culture and sense of community: bring in diverse speakers and postdocs and faculty. Sponsor your faculty and researchers to give lectures at historic Black universities and colleges and Hispanic serving institutions. Host graduate school previews where you bring in diverse students as college juniors, seniors, and master's students to look at your program. Participate in diverse conferences and advertise on diverse listservs. Job ads in SACNAS and NA Black Geosciences and so on, and other listservs. Post internal positions on appropriate virtual bulletin boards, and have your search committees have training in implicit bias and diversity and inclusion hiring practices. If you're interested in more information, I will point you to a Vision and Change document in the Geosciences. It's coming out this fall. It's the results of an extensive 6-year NSF-sponsored initiative that's involved over 1,000 geoscientists. And in addition to more on recruiting and retaining underrepresented minorities and other students, there's extensive information on concepts, competencies, and skills needed for both graduate and undergraduate students in the geosciences, pedagogy, curriculum redesign, and more.